All right, 58 requires a little bit of work to figure it out. Okay? So we got TC3 and BO3 in parentheses and a 7 outside. All right. So we have more than 2 elements here. So what am I going to look for when I'm naming this? A polyatomic ion. Okay.
It's not.
That's not a polyatomic ion?
It's not on the list. It's 4A.
There it is.
Oh.
I didn't even see it.
Even if it got the 3 months. Yeah. That's just a charge. It's got a 3 months.
That's just a charge, that's right.
So that's not in the that wouldn't be in the formula.
You no, because it can't. Once you build the formula, the charges cancel out. Okay. All right. So BO3, 3 negative, is borate. Okay. Now we need to find TC. Well, that looks like an element, doesn't it? Capital letter, small letter. Technetium. You're going to go if you don't know where to find that. That's on the periodic table. Okay, so there's technetium. Okay. So TC is technetium. All right. Now, if it only has 1 oxidation number, that's all we have to do. But if technetium has more than 1 oxidation number, then we've got to figure out which oxidation number fits it. And for that, then to find out if there is more than 1 oxidation number, we're going to go to the periodic table with oxidation numbers. And it looks like this. And let's see, here's technetium, and guess what? There are 3 different oxidation numbers. So we've got to do some math to figure it out. All right. We know that the borate has a 3 negative charge. And we know from this 7 right here, there are 7 of them. Okay? Technetium, we don't know its charge, so what we want to figure out. So we've got a blank space here, but we're going to multiply it by 3. So the subscripts, remember, are multiplying everything it's next to. Okay? So when we get done, as I said a minute ago, once you put the formulas together, once you put the whole formula together, all the charges are canceling out. So we're going to have a 0 charge when we're done. So we can use this then to figure out what charge goes right there. 7 would go there and fix it, wouldn't it? That would give us a 21 plus a 21 negative, and that does equal 0, doesn't it? Okay? So that must mean technetium has a 7 plus charge. Let's double check and make sure, and sure enough, there is a 7 plus charge right there available. So then the name of this must be technetium 7. Okay, Roman numeral 7. Because that's the charge on the technetium. Whenever you have a metal and an ionic compound, if the metal has more than 1 oxidation number, you have to name it with a Roman numeral to indicate that charge. Okay? Does that make sense?
Yes.
All right. Good.
Number 59, I think that's what you. Yeah.
59. H2CO3. All right, I got hydrogens on the front. What kind of a compound is going to have hydrogens on the front?
Acid.
An acid. Okay? So we know it's some kind of acid. What we have to do is figure out how to name it. Now, the way we name acids is we start out naming it like it's an ionic compound, and then we change the name to an acid name based on the type of acid it is. Okay? So if this is an ionic compound, we've got more than 2 elements here, so there must be a polyatomic ion in there somewhere. Let's go back to that common ions list then, and we'll find some part of this formula on this, or we hope that we can find it somewhere on this common ions list. And there is, that CO3 is there, and there's CO3, and that's carbonate. Whoop, carbonate's right there, CO3. Okay? So we know the back part of this is going to be called carbonate. It's a carbonate ion. What?
Don't you drop the hydrogen?
Well, yeah, we're going to get to that. But I want to go through the whole thing so I can explain when you drop the hydrogen. So if we're naming it like an ionic compound, then we're going to name the first thing just what it is in the periodic table. This is not a metal, so I don't have to worry about Roman numerals here. This is just simply hydrogen carbonate. All right, so that's the first step, naming it like an ionic compound. The next step is to change that name to reflect the fact that it's an acid. When you have an acid that has a polyatomic ion, when an acid contains a polyatomic ion, you drop the word hydrogen off the front entirely. Well, we don't know. It's not that yet. Okay? And 8s become X. Ites become us. Okay? In binary acids, the ides also become X. But with binary acids, you also put hydro on the front. So the 8 here is going to change to ic. And then we're going to add that name acid on the end as a separate word. So the name of this acid then is carbonic acid. Okay? What did you say? Well, let's see. Acetate. What would that ATE ending tell me? Huh? Not an acid. Acids have ic and us endings. What would that 8 ending? It's a polyatomic ion. So where are you going to go to find the formula for a polyatomic ion? The common ions list. There it is.
And we could choose whatever one we wanted to.
Sure, all three of those are the same thing, just written in different ways.